faint vibration inside a conveyor motor wasn't supposed to mean anything, yet the algorithm watching it flagged the shift instantly, long before anyone knew a contaminated batch was forming downstream. That single alert revealed something uncomfortable. Defects can start long before they look like defects, and artificial intelligence had seen what dozens of inspections never would. Across modern food plants, this pattern is repeating. AI systems are catching microscopic clues, abnormalities in patterns, and deviations in behavior that were invisible to the human eye. Within seconds, they reconstruct what could go wrong before anything actually goes wrong. To understand why this shift matters, consider how inspection traditionally works. A technician examines a cross-section of the day's production. A lab receives a sample, incubates it, analyzes it, and waits. If the sample is clean, the batch is assumed clean. If it's contaminated, everything stops, often too late to prevent distribution. The flaw isn't the people, it's the silence inside the system. Contamination doesn't appear in every sample. It appears in pockets, in brief moments, in places no one is looking. And that's where AI changes the inspection landscape. Instead of checking a few points, AI monitors thousands. Every vibration, temperature shift, light reflection, surface texture, pressure reading, airflow deviation, and ingredient pattern becomes part of an enormous stream of data. Not for humans to interpret, but for models trained to detect the slightest inconsistency. One of the hidden mechanisms behind these systems is anomaly detection. The AI isn't searching for specific contaminants. It's searching for anything that shouldn't be there. A shadow on a conveyor camera, a density change in an X-ray profile, a temperature dip at the wrong second, a spectral pattern that doesn't match the baseline. When those anomalies line up, even faintly, the AI raises a signal. And the surprising part is how early those signals appear, long before the defect becomes visible, long before the product reaches a sampling station, long before a consumer could ever be at risk. The first value spike comes here, the uncomfortable realization that contamination is often detectable only through patterns, not through sight, smell, or manual inspection. In other words, AI doesn't need to see the contaminant, it only needs to see the disruption it creates. This explains why some factories are discovering issues they never even knew existed. A metal detector that occasionally misreads, a mixer that vibrates slightly when a bearing wears down, a filler that creates micro-air pockets when viscosity changes. Each tiny deviation becomes part of a larger story the algorithm pieces together. But the second value spike arrives when AI goes beyond detection and into prediction. By scanning historic data, ingredient behavior, equipment aging patterns, and environmental shifts, the system can calculate when the next failure is likely to happen. Not in theory, in time-stamped actionable forecasts. A recall predicted hours or even days before the defective batch forms. Food plants have never had this kind of foresight. Regulators haven't either. Inspection was always a snapshot. AI turns it into a live map. This leads to the third value spike, the reversal, where the role of the human inspector changes. Instead of searching for the problem, inspectors now verify the alerts generated by machines. Oversight shifts from detection to interpretation. The inspector becomes the second line, not the first. That raises questions. If AI becomes the primary guardian of food safety, what happens when it misreads a pattern? What happens when the system flags too much or too little? And who takes responsibility when the algorithm makes the call? Those concerns are shaping new conversations in the food industry. Some plants are designing rule sets that require a human to sign off on every AI recommendation. Others are training inspectors to understand data signatures instead of surface defects. A few are experimenting with hybrid models where AI validates the human, and the human validates the AI. Yet even with these debates, one thing is becoming difficult to ignore. The safety net is widening, the blind spots are shrinking, and inspections are moving from snapshots to continuous awareness. In the end, AI isn't replacing the inspector. It's reshaping the environment the inspector works in, an environment where the earliest warnings come not from what is seen, but from what is sensed. Somewhere inside a factory, another vibration shifts, another light pattern flickers, another data point drifts away from the curve. The system notices quietly, long before anyone else does. And it raises a question for the future. If machines can detect what humans never could, how much of tomorrow's food safety will depend on trusting what we cannot see? The transition has already started, and its impact is only beginning to surface.